kind of reluctant. It's unfortunate I'm on the beginning of the program because I'm going to talk about some things that might be a little controversial, and you're going to look at me at some point and go, that guy's a crackpot, okay? So I'm going to predict the future, and I love doing that because I'm not going to be around, you're not going to be around, so we don't know whether or not what I say is actually going to ever materialize, right? Okay? Well, the future I'm going to predict is probably going to be a little bit closer than maybe we'll all still be alive. I think it's going to occur in about the next 10 to 15 years. And so I'm going to try to justify everything that I do as I go through here, and hopefully you'll see why I think things are going to change and move in the direction that I'm suggesting here. An agenda, I'll try to stick to this. Sometimes I kind of get off in the weeds, but hopefully at the end we'll try to tie everything together. So, how big is too big? That's not photoshopped. That's actually a planter that's marketed by John Deere. It's a Bower-built toolbar, 48 rows, 120 foot wide. This thing was debuted at the National Farm Machinery Show in Louisville a few years back. The interesting thing about it is they could not unfold it indoors because of the fire marshal. You have to have a 10-foot aisleway every 100 feet. They couldn't even unfold the planter inside the building. Okay? Once you look at that planter, and for those of you that are kind of familiar with agriculture, there's something very unique missing from the planter. You see it? Look on the ends of the planter. Over here. What usually hangs out here? Row marker. Why isn't there a row marker on it? Think about that. 120 foot wide, that would have to be a 60-foot row marker. Now, let's go one step further. Think about the farmer turning at the end of the field and catching the row marker in the fence row. Okay? What would a 60-foot row marker cost to replace? That's not really the major concern. The major concern is what catching that row marker in the fence row would do to the frame on the planter. Okay? And this is kind of a precursor to my entire conversation today because that row marker has been replaced with technology because technology is cheaper. Specifically, what's replacing that row marker on this planter is auto steer on the tractor. We don't need row markers anymore. In fact, auto steer on the tractor and GPS on the tractor automatically guide the tractor is cheaper than the row marker. Think about how things are going to change going forward. By the way, this isn't happening just on 48 row planters. It's happening on a lot of other things. Another thing, how big a tractor do you need to pull a 48 row planter? Anybody want to hazard a guess? How many horsepower? 300, okay? John Deere actually recommends a 400 horse tractor to pull that planter. The reality of it is a 300 horse tractor would pull it. The problem is when you fold it up, you need a 400 horse tractor because of the weight on the tongue that's put on the rear end of the tractor. Think about this. How big is too big? And do we see anything in sight that's going to stem the change in the size of equipment? What limits equipment size today? Shipping weight, transport width, available power, total vehicle weight. I'm going to come back to that total vehicle weight, but we're really getting to the point where tractors coming out of the factory are going to have to be disassembled to be trucked, or you're going to have to get oversized permits for everything. Okay? I used to use this all the time because it's one of the bigger tractors. That has a Cat C18. Anybody who's into that? That's an 18-liter engine. 622 horsepower. Ballasted mass on that tractor is 60,000 pounds. Why is that important? Well, for every engine horsepower, you need somewhere around 110 to 130 pounds of tractor mass. If you don't have the tractor mass, you might as well not have the horsepower. Okay? By the way, if you got that tractor mass, you have to have enough tires to support it. See where things are headed? Fuel consumption on that's 33 gallons an hour. $4 a gallon. How'd you like to pay the fuel bill? 16 hours in the field each day? How'd you like to pay the fuel bill on it? Life of that tractor, 20,000 hours. That's a good thing, right? Realization. In the Midwest, tractors are used about 500 hours a year. Now, I use that number to make the math easy. What's 20,000 divided by 500? 40 years. That tractor is going to be on a U.S. farm for 40 years. Well, I submit to you there's a lot of farmers still using John Deere 4020s out of the 1960s. Okay? Had a gentleman in my office, he was a colleague of mine from undergrad at Ohio State University. He is now managing the R&D budget for John Deere for their Precision Ag group. He laughed at me when I said that tractor had a life of 40 years. And we're sitting there talking, and finally I looked at him and I said, Jerry, I said, how long are you going to support the electronics on that tractor? How long, in this case, is John Deere going to support the electronics? He quit laughing. And he kind of danced around the question, and finally I pinned him down. I said, Jerry, tell me how many years you're going to support it. He said, 14 years. Think about that. We have a machinery company that's making the statement they're going to support electronics on that tractor after the sale for 14 years. Now certainly other people will come along in the marketplace and support it. That's not the problem. But think about that. They're designing equipment with potentially a 40-year life, and they're going to support it for about a third of the life of the piece of equipment. Interesting. I'll come back to that. I put this graphic up there. I say we did this. What I really mean is I had an undergraduate student that I paid just slightly above minimum wage to do this. Went to the University of Nebraska tractor test, got all the data for John Deere tractors. I'm not picking on green tractors. The only thing I put this up here for is just a complete data set for one manufacturer. These are the ballasted weights as the tractors were tested. Starts out in 1920, goes to 1960. I kind of put this yellow line in. We look at the rate of increase in the base weight of tractors tested at the University of Nebraska. And you notice it's a slowly increasing rate right here. What happens in 1960? It takes off. What happened between the 20s through the 60s and 60s on? We went from spark ignition engines, kerosene burners if you will, to diesel. And look what's happened. Now, I'm suggesting to you that if we look at that envelope, the heaviest tractors or the highest horsepower tractors built by John Deere have increased an average of 900 pounds of mass per year sustained for 50 years. Is anything going to stop that trend? I just showed you a 632 horse tractor. Is anything stopping that trend? Europe, they have some problems because they have a transport limitation. It's a 3 meter or 3.5 meter transport limitation. They can't put dual tires on their tractors because if they're driving down the highway, they'd have to take the dual tires off. The only thing the Europeans can do, and this is a concept tractor, is what? Put more axles on the tractor. You either got to go wider or you got to go longer. Okay? Again, is tractor size going to stop increasing? I was up at Firestone Tire. I got to remember it. Yeah, hopefully you got the right one. You got the. Sometimes I put a lot of different PowerPoints on there, but I was up at Firestone and they were talking about this RCI index, and one of the engineers kind of slipped a little bit and said they're going to build a tire with an RCI 52. Okay, I'm an engineer and I get excited about numbers like this, and the RCI doesn't mean a whole lot to you. It's a rolling circumference index. It's used to match up tires on tractors with front wheel assist. I can go into the technical aspects of it, but he said 52. So I came back and I graphed. This is the tire outside diameter, and this is the RCI index, and this is what's currently manufactured. They go up to a 50. Now they're going to a 52. We go up there and hit that and come across. We're going to see a row crop tire. Okay, when I say a row crop tire, the width of the tire will fit down between 2 rows of corn. We're going to see a row crop tire 100 inches in diameter. Anybody got a feel for that? Somebody's getting ready to build a 750 horse tractor. Okay? Why would Firestone be building a tire 100 inches in diameter for a row crop application? Somebody's getting ready to build a tractor, 750 horse. Anybody see this at the Farm Science Review? That's 700 horse. That's a concept tractor. It's come out from New Holland. It'll be available to farmers soon. 700 horse, I want you to do the math, 120 to 130 pounds of tractor mass per engine horsepower. And how heavy is that tractor? 85,000 pounds? What's the limit for moving goods and services on public highways in the state of Ohio? 80,000 pounds? How are you going to haul that thing? Hey, you can get wide load permits or oversized load permits, but think about that. Okay? This is today. I'm not talking about something that's futuristic. This is today. Combines. Probably one of the major purchases a lot of farmers make. This is a Class 9 machine. You probably don't have to go too far. My guess is they probably have one of these up at Wellington Implement. Okay. Corn head 16 row, 40 foot wide. It's got an Iveco 12.9 liter engine at 523 horse. Grain tank will, I'm sorry for these numbers here. I probably shouldn't have done that. Grain tank's 400 bushels. That sounds a lot better, doesn't it? Okay. Loaded mass, that's not too bad, 35 tons. Harvest rate's about 29 acres per hour. I guess that is English units, 11 tons, 400 bushels. I know that you can load this machine in about 220 seconds. 400 bushels. That machine will harvest about maximum of 100 to 105 bushels a minute. Okay? 100 to 105 bushels a minute. I know that because that's the way they size the clean grain elevator. And I know that a farmer can't go any faster than that because if the clean grain elevator doesn't take the grain to the top of the tank, where does it end up? For those of you that are from farms, it ends up on the ground as it goes out the back of the machine. So I know that they're never going to harvest any faster than 100 to 105 bushels a minute. Load the tank in 220 seconds. It takes almost 2 minutes to unload the grain tank. Now, why am I telling you that? What do farmers use today to keep that machine in the field and keep it operating? Do most of them have tractors with grain carts? What I'm telling farmers today is if you buy that machine, it's a Class 9 machine, in order to take advantage of the harvest capacity, you better have the unloading auger out on the machine and you better have it turned on every bit of the time that machine's in the field, which means you got to have a grain cart underneath it. Now let's go ahead and do a little bit of math here, and this is theoretical. 100 bushels a minute, that's, what's that, 6,000 bushels an hour? And what can you get on a tractor trailer? Well, okay, farmers put 1,000 on there, but you're really not supposed to, are you? Unless you got some new miraculous material. There's a lot of farmers that will put 1,000, 1,100 bushels on there as long as they don't get caught by Department of Transportation, right? And those guys, they got those portable scales now, too. And they'll get them out of the trunk of the car and they'll weigh your truck, and it's not pretty if you get too far overweight, okay? But think about that. Theoretically, and it won't do it, but theoretically, 6,000 bushels an hour. How many trucks do you need to keep that combine in the field? Tractor trailers I'm talking about, the ones going back and forth between the elevator or the grain setup at the farm and the field. You need a fleet. Most of these guys are on a Class 9 machine, especially if they have any haul distance at all, will have 5 tractor trailers. Now they may only have 3 or 4 drivers, okay? But think about their grain setup now. You have to have a dump pit that's going to handle 1,000 bushels so you can dump your truck and get back to the field because your machine's out there still running. Think about the grain dryer. You know, every time you buy another piece of equipment in this cycle, everything else downstream represents a potential bottleneck. And if your grain dryer won't dry grain fast enough, can you take advantage of the harvest capacity of the machine? Can you take advantage of the grain cart and the tractor that you have in the field? Can you take advantage of the 5 tractor trailers that you might have on the road? And so farmers face this. And so when you buy a new combine, pretty soon you find yourself buying maybe another truck, a bigger size grain cart, increasing the dryer size back at the farmstead. By the way, what's happening to grain yields? Anybody paying attention to that? Interesting scenario, isn't it? I talked to the manufacturers, and I was showing you Class 9 machine, and I asked them, what's a Class 9 machine? They can't tell me. These are the manufacturers. I'm talking to the engineers. What's a Class 9 machine? They tell me it's bigger than a Class 8 machine, which was bigger than a Class 7 machine. Okay? So I thought for fun, I just went out and got all the new product literature for combines that were available in the U.S. These are the big 3. Oh, I think I threw in, well, AGCO, C&H, Case New Holland, if you will, John Deere. And I plotted them here. And what I found out, really, it's engine horsepower. The size of the machine is really engine horsepower. Everything else has to be there to take advantage of it. So I projected kind of going out in the future. A Class 10 machine is going to be 565 horse. What the heck, a Class 13 machine is going to be about 760 horse. Is anybody going to build a Class 13 machine? We know there's a manufacturer because there's some pictures that have shown up on the internet, and they're building a Class at least 11, more than likely a 12, maybe even a 13 machine. Okay? How many trucks do you need to keep that in the field? Okay, let's talk about automation a little bit. And this is kind of a sobering thing. What's corn prices right now? Anybody following cash grain?
Just over $4.
Yeah, man, that's a heart stopper for a lot of people, isn't it? You know, we go back last year and there were a lot of people marketed grain at what, $7 a bushel? Corn? Yeah, well, at least they got more yield this year. Okay, that's a good thing. All right, so if our machine's able to harvest 6,000 bushels, 6,000 bushels an hour. If we're able to harvest 6,000 bushels an hour, that's worth $4 a bushel. I'm going to round it off. That's $25,000 an hour. I think I want to get a high school kid at minimum wage to run that combine. Yeah, what I'm suggesting is farmers don't spend enough on the operators of that equipment. Here's kind of an interesting thing. New Holland came out. They got a couple things going on. They got something called a grain purity cam, and what they're able to do is look at the grain and assess the quality of it that goes through the machine. What this really means is now you can assess quality. You can make adjustments to the machine automatically. Interesting. They got this IntelliCruise system where they look at the loading of the machine and they adjust the ground speed. Because what you want to try to do is keep the cylinders full when you're threshing to minimize grain damage. Also increase throughput through the machine. By the way, one of the things I didn't mention, there was a gentleman from Purdue, one of your counterparts, I think, Howard Doster. You remember that guy?
Oh, yeah.
Great man, isn't he?
Yeah.
Howard Doster used to talk about farming in combine units. Okay? In other words, you got to farm enough ground to cash flow. If you're going to buy a new combine, you're going to have to farm enough ground to cash flow that machine. Howard Doster used to talk about farming in combine units of 3,000 acres. That's when you had Class 7 machines. You get to a Class 9 machine, how many acres do you need? 4,000, 4,500, 5,000? Think about this. So if you buy a second machine, how many acres do you need? Combine units, okay? When I look at this, can a farmer, let's say that this automated control system that's coming, they're all working on it. Let's say this automated control system, what's a new combine cost? Anybody had anybody in to borrow some money on a new combine? Oh wait, they're just paying cash these days, aren't they? Yeah, I mean, you'd get $500,000 tied up in one of these machines pretty quickly, couldn't you, if you buy a couple heads for it, a new machine, okay? Let's say this system that I'm telling you that's coming cost, let's say it cost, I don't know, round number, $50,000. And let's say it reduces harvest loss by 1%. Can the farmer afford to pay for that system? Let's see, 1% of $25,000 an hour. How long would it take you to recoup $50,000? A couple of years? All I'm saying is we're going to do things with technology because it's affordable to do so. And as the size of the machine increases, the last thing you want is a human operator making a mistake, because it ends up being a very expensive mistake. Okay? I don't know where things are going. Oh, hey, just get a bigger grain cart. I told you that, didn't I? You know, there's three companies making 2,000 bushel grain carts. Think of that. You pull up to the road, you got two tractor trailers sitting there, and you fill both of them. By the way, the unload time on this, 120 seconds. You fill both tractor trailers in 2 minutes. I was with a group of farmers, and one farmer raised his hand and goes, Dr. Shear, you can't fill 2 tractor trailers in 2 minutes with that. He said, you can unload the grain cart, you just can't get all the grain in the trucks. Think about that. Think about standing underneath the auger and somebody accidentally kicks it on. Unload time, 120 seconds. Wow. By the way, grain carts are getting bigger necessarily. When you had a 400 bushel grain cart or gravity wagon, the steel required that on a per bushel basis wasn't all that bad. But all of a sudden you get out here to 2,000 bushels, out here somewhere, you need a lot more steel to support each bushel. So necessarily as grain carts get bigger, they get heavier. Are we worried about compaction anymore? You know, I submit to you, there was a really neat place. USDA had the National Soil Dynamics Research Laboratory in Auburn, Alabama. Back in the 50s, 60s, and 70s, that lab was in its heyday. They were working on traction, they were working on soil compaction. You know, back when we had those massive 100, 125 horse tractors, they were concerned about compaction. My conclusion is that laboratory's changed its mission. They're now worried about soil carbon. Since that laboratory changed its mission, I've been left to conclude we no longer have a soil compaction problem. Is that fair? We must have solved it because the USDA doesn't consider it a problem anymore. Oh well. Maybe they make mistakes too. I think we have a soil compaction problem. Here's an interesting machine. This caught some farm press a little while back. This guy decided to put together a grain cart and a combine. I'm thinking this is a pretty stupid idea. I'm kind of blunt, aren't I? I'm sorry. And I probably wouldn't tell the gentleman that. It was him and his sons that put it together, but you know, farmers have tractors, and tractors are usually going to sit in the barn and harvest unless you got hooked to a grain cart. Grain carts really are pretty inexpensive. Think about this. You're going to use your combine, you fill the grain tank up, and then you're going to drive to the end of the field while you're not harvesting grain to get to the truck to unload it. Saw that harvest capacity that you bought, you just cut it in half. Okay? Farmers need to buy complements of machinery that advance their ability to manage their ground. Again, there might be some farmers that might need this, but I think it's a stupid idea. I'm going to get myself in trouble. By the way, my greatest fear is that Bruce McPherson, the new vice president, finds out about some of the presentations that I give. Okay, so don't say anything to him, Rory. Capitalization remains problematic. Well, not when you got good grain prices. Okay, I submit to you right now, if grain went to $2 a bushel, corn went to $2 a bushel, U.S. equipment manufacturers wouldn't sell any new equipment for 5 years. Think about that. Here's the example I'm going to use. I got a good friend of mine farming over in west central Ohio. He had a John Deere 8000 series tractor, farmed with it for 6 years, sold it for $15,000 more than he paid for it. Heard these stories? Well, goes out and buys a brand new 8R. Okay? So the following year he says, well, that 8R is too big to pull my gravity wagons in the field. So he bought a 7R. This is a John Deere. I mean, we're talking large two-wheel drive tractors. And I said, Rick, why are you buying a 7R? He goes, well, that 8R is too big. I said, Rick, how many horsepower do you have on the farm now? The thing you don't know is Rick's farming 450 acres. Okay? What I've been doing and trying to get farmers to do is take the total number of horsepower that they use to farm with and divide by the number of acres. Reasonable numbers for reasonable farmers are somewhere below 1 horsepower per acre. If they're no-till farmers, they ought to be down around a half a horsepower per acre. If they're doing tillage, maybe 0.7. When you get farmers that are 1.2, 1.3, 1.5 horsepower per acre, you got to ask what's going on. Okay? Now, in Rick's case, he's profitable, got all of his land paid for, and Uncle Sam's going to take part of his money. And I never thought I'd say this, but I think Rick views tractors as an investment because he made money on the last tractor he bought. Has that ever happened in the history while you've been lenders? Farmers buy machinery that appreciates in value? Tell me when the last time that happened was. I don't ever remember it in my lifetime. Evolving technologies, this is the game changer. Control area networks on tractors. I better see what I'm doing on time here. How much time do I have left, Rory? Oh, good. That would be just perfect. I have 45 minutes of material left. CAN bus, control area networks on tractors. There's a bunch of ECUs, electronic control units on tractors, and they're on an asynchronous bus. There's a lot of jargon and terminology here. What's happening is that tractor can have up to 17 million different pieces of data put on that bus, different unique pieces of data. Okay, that data is roaming all around that bus. When you hook up the planter now, you got to drop the hitch pin in, you got to hook up the hydraulics. Oh yeah, you got to hook up the tractor bus. You got to hook up the computers on the tractor, the computers on the planter. Okay? This is changing the way we do agriculture. And I'm going to show you some of the ramifications of it. In cars now, they've added something called FlexRay. There's communication buses in cars now. We're going to start having cars talking to cars. Anybody hear about the Google car? What do you know about the Google car? Driverless. 400,000 miles, not an accident yet. Well, there was an accident, but that's when one of the Google employees was actually driving the car. Two engineers from a machinery company go to see the Google engineers. True story. The Google engineers get in the front seat. The two engineers from the machinery company get in the back seat, and off they go down the road. The Google engineers pull over the side of the road, and they go, something's not right. Get out and go back and open up the trunk. Two engineers from the machinery company sit in the back seat. The Google engineers close the trunk. The car starts up, takes off down the road with the two engineers from the machinery company in the back seat. Accelerates to about 45 miles an hour. There's a crosswalk. There's a gentleman that walks into the crosswalk. These engineers in the back seat, they don't know what the heck to do. The car slows down. The person in the crosswalk passes in front of the car. The car speeds up and accelerates, goes down the end of the road, turns around, goes back to where the two Google engineers are, and they're standing there laughing. The engineers from the machinery company weren't too amused. They might have been unloading their drawers or something at the end of this, but the bottom line was the engineers from Google said this is the most effective way that we can demonstrate to you the capabilities of Google car. 400,000 miles. By the way, California allows that on public thoroughfares now. Where are things headed in agriculture? We hear a lot about drones, don't we? Unmanned aerial systems. By the way, this FlexRay, it's a new bus. It's got this communications thing for entertainment, okay? And then it's got all these things for essentially communication between vehicles and things like that. It's coming. It's going to be on tractors. Control area networks are reaching the limit. One of the things that's happened in Ohio, Ohio is a very fortunate state. All these little dots right here represent RTK, or GPS if you will, base stations. State of Ohio has densified what they call their Coors network. That's C-O-R-S, not C-O-O-R-S, okay? They've densified their Coors network. All those base stations, GPS base stations, are all internet connected. And a farmer now, through a cell phone modem, can log on to the Coors network and get an RTK correction signal. They do that anywhere in Ohio. One of the problems is the green people won't allow farmers to use the Coors correction signal provided free by the state of Ohio, Ohio Department of Transportation. But all the other manufacturers do. So it's an interesting time. It used to be when farmers wanted RTK GPS, yes, it's a marketing thing. You know, the green people want to sell green. I better quit beating up John Deere. They're going to come get me. Okay? There's probably a John Deere plant in the audience someplace listening to me talk. So, look, John Deere's a marketing organization. I think there's some standardization coming. I think John Deere is very concerned about standardization. But, you know, hey, I see where they're coming from. You know, there's a lot of green people out there. They won't buy anything but green equipment, too. And I respect that. John Deere equipment has pretty good resale value. And, man, they're a heck of a service organization, too. So I'll say some things that may not be kind, but I'll try to balance that with things that are kind. Number one user of the Ohio Department of Transportation Coors network, agriculture. 70 to 75% of the load is agriculture. Why did ODOT develop it? They didn't develop it for farmers. They developed it for control of the road network in the state of Ohio. Basically, they developed it for surveyors. I talk about this because this whole infrastructure is evolving, and I'm going to get to the very end. Did anybody hear anything about Light Squared? This was under ARRA funding, American Reinvestment and Recovery Act, okay? In the Obama administration, what they wanted to do is make broadband internet access available in rural America, okay? But what they were going to do is they were going to broadcast it at 1,600 watts, and the problem was that 1,600 watt signal was very close to the GPS signals. So effectively, it was going to render all the GPS equipment that had been sold up to date useless. And finally, the FCC stepped in and said, nope, we're not going to allow this to occur. And the machinery companies were relieved. But what I'm telling you is, probably one of the biggest mistakes ever made by the machinery companies was blocking Light Squared. Okay? Light Squared was going to broadcast over here, kind of these two frequencies on this end of the electromagnetic spectrum. Okay? They're 1525 megahertz up to about 1560, 1550. Right here was John Deere's Starfire correction signal. If we look right here, here's the GPS signals. And over here's GLONASS. This is the Russian satellite system. By the way, most of the receivers being sold today pick up GPS, which is the U.S. system. GLONASS, there's also a European one that'll never be built. I'm sorry. A European one that's a few years off, okay? But all these receivers now lock onto all these signals. So FCC canned broadband internet access for rural America through Light Squared. one of the things I said was, it really was the worst thing that could have happened, because now what we really need is broadband internet access in all of our tractors and combines and things. And I'll show you why we need that. Right now we got cell phone modem connectivity to these machines, but you just can't push enough data through it. Okay? Next generation of machines. Here we go. Carnegie Mellon's been doing this. Anybody seen a peat moss harvester? It's a big vacuum cleaner. You drive over the peat bog, you vacuum up peat moss, take it over, bag it, sell it, homeowners buy it. No driver in the tractor. There's 2 of those. This is the Demeter project, C&H, Case New Holland. Well, this was New Holland at the time. This mower conditioner would start up, self-propelled, go out and mow and condition a field of alfalfa hay, 40 acres, go back to the barn, absolutely no human intervention. Golf course mowing equipment, fully autonomous. By the way, this happened back in the 1990s. Okay? Some interesting things going on. These are all concepts. This is down in Florida. Okay? They're doing a lot of mowing of citrus groves. This was John Deere's concept tractor built on the 5000 series tractor. Bob Recker put that together. Really neat engineer from John Deere. I like the guy. He's a really talented individual. John Deere Gator R. You ever seen the Gator for the military? Retail price, $320,000. Got to see a demonstration of this on the University of Illinois campus. Gentleman from John Deere's Tech Center, brought that Gator out. And he put it on the mall out there outside the library. I think it was the agriculture library at the University of Illinois campus. About 150 engineering students inside, and the guy from John Deere gets out a little PDA, punches a few buttons on it, sticks it back in his pocket, and he goes, watch this. Young lady comes running by on the sidewalk. The Gator starts up. He gets to follow her. She doesn't know what to do. She runs faster. It speeds up. She slows down. It slows down. She runs off the sidewalk. It runs off the sidewalk. She stops. It stops. She walks towards it. It goes into reverse and backs up. This poor young lady didn't know what to do. This was basically designed for the battlefield, and there's instrumentation allowed on that machine to allow it to follow a soldier in the battlefield, maintain about a 30-foot distance between the soldier and the machine. Okay? John Deere, aspirations of getting in to providing military hardware. One of the things you have to understand is a lot of things from the military transition or translate directly to agriculture. I was just at Wright-Patterson Air Force Base yesterday morning with their sensors group, looking at a lot of the technology out of Afghanistan. There's applications in agriculture. It's coming. This is John Deere's Intelligent Total Equipment Control System. Okay? This was marketed back in 2008, and the reason why I show this is, I needed to show the YouTube video. It used to be up for a while. What you could do is, it's kind of like a macro. Most of you are familiar with a macro in a spreadsheet. You know, punch a button and all these calculations occur. In this case, there's all these controls over here on the armrest, and the farmer at the end of the field has to do a number of things to pick up the planter, slow the tractor down, slow the engine down, turn the tractor around, then they have to do all that in reverse to start planning the next trip. Okay, and the farmer can record that macro, so turning around at the end of the field becomes a button push. Okay? Capability is already on the tractor, has been there since 2008. Part of it's because of the control area network, or CAN. Okay? YouTube video, a gentleman sitting in a lawn chair along the edge of the field drinking what appears to be a refreshing fermented beverage. His tractor comes up, nobody in the tractor cab. This is about 3 or 4 years ago. Comes up to the end of the field, is being guided with GPS, turns around automatically and starts back in on the next pass. Nobody in the tractor. Okay? 4 or 5 years ago. This technology's coming. John Deere and C&H both announced products called, well, basically it's vehicle-to-vehicle communication. But at harvest time, the tractor with the grain carts gets close enough to the combine takes control of the tractor and drives the tractor during the unloading process. A lot of the times, the person operating the tractor can't see the grain cart because it's so tall. And it's difficult to load the grain cart evenly. There's now technology coming from John Deere that will allow the combine, in coordination with the tractor, to load the grain cart evenly. It's here. It's today. Okay? Anybody heard of the company by the name of Kinze? John Kinze-Baugh. Okay, he's from Iowa, isn't he? Yeah. Great entrepreneur. Fantastic gentleman, and please don't let this get back to him. I don't want to make disparaging remarks about John Kinze-Baugh, okay? But basically, his business, he's a metal bender. He welds metal together and he paints it. And he does a really nice job of all that, doesn't he? Okay? Builds grain carts and planters. By the way, he had a little run-in with John Deere on patent violation or something. They finally got it worked out on the courthouse steps with some attorneys and some things like that. But John Kinze-Baugh teamed up with J-Bridge Electronics And now they have a drone tractor that will go out and plant automatically. A metal bender is in the robotics business. That's unheard of, isn't it? Oh well. Fendt has something called Guide Connect. There's an operator in the front tractor, no operator in the back tractor. You got one person supervising multiple machines in the field. Today, John Deere's FarmSight. You need to be paying attention to this. When farmers buy a tractor over 200 horse from John Deere, a combine, a sprayer, or a cotton harvester, we do a lot of cotton in Ohio, don't we? When they buy those machines, they automatically get a cell phone modem integrated into the bus on the tractor. And that cell phone modem will automatically broadcast data to John Deere's cloud about the performance of that equipment. Telemetry. Everybody has telemetry now, but moving data from the machines to the cloud. John Deere, to kind of demonstrate this, they had a farmer just bought a new 8R tractors out in the field. Gets a call from a young lady in Des Moines, Iowa. I think the farmer was in the middle of Illinois. Young lady says, "Sir, could you please stop your tractor and check the hydraulic reservoir?" Young lady, "I checked that before I started. I'm okay." "Sir, we advise you to stop your tractor and check the hydraulic reservoir level." "Ma'am, I just checked it before I started." "Really, sir, you ought to stop and check your reservoir." Got out of the tractor. There was a hydraulic hose that broke, and he'd been pumping hydraulic oil out into the field. John Deere recognized it before the operator of the piece of equipment did. Think about where things are headed. There's identifiers that'll tell you on the bus, it'll tell you when that door opens, the cab door opens, when the tractor's parked, when it goes out of a geographic fence. Going forward, you'll love this one. This is what we're doing at Ohio State, because you know I got to have a research program. I just can't go around talking about it. Well, what it really means is I got some graduate students back there doing the work. Okay, we're working on control systems for fleets of vehicles, and to give you, what we're trying to do is give the tractor intelligence. That's what the tractor's missing right now. You got to have a human operator on there because you need intelligence. But you know, we can set an A/B line, and using GPS, we can guide the tractor automatically. And oh, my phone keeps beeping. Sorry about that. There's kind of a deliberative mode. It's going to drive from point A to point B. But maybe there's an obstacle that occurs out in the middle of the field. Okay? So along here it senses an object and it goes, "Oh gosh, I got to do something." Okay? Now maybe that's a rock, maybe that's a tree, maybe that's something that's immovable, and the decision is, hey, just go up here and drive around it. I want to try to get you to give you a feel for what's going on in the industry in terms of liability. Okay? By the way, that person was using auto steer when they hit that. Okay? And that was with the human operator. Humans are fallible. Think there's any liability associated with that? What we're trying to do is guide fleets of vehicles. And so we're not just worried about the combine. We're not just worried about the grain cart. By the way, I think that's unloading on the wrong side, isn't it? Did you notice that? Maybe I need to do a mirror. We're worried about the grain cart that's coming up behind that to be filled or loaded next. Okay? Fleets of vehicles. This is some of what we're doing. We built these little electric vehicles to go in the parking lot. Okay? Here's our control area network. Our wiring isn't quite as nice as John Deere, Case IH, and things like that. Here's our new version. We're working on that. We'll release that here pretty soon. But what we're doing is we can take the laptop off of here. We can plug it into the diagnostic port on this tractor, claim an address, and take that same algorithm that we used on that small electric robot and control that 340 horse tractor. It's happening. Planters. Man, it used to be you just went out and bought a planter. Today you got so many decisions to make. The controls on planters are really out of control, okay? Literally, farmers now have the option of putting up to $2,000 worth of controls on each single row unit. You buy a 24-row planter, you might have to spend another $50,000 on sensors and controls for that planter. It's here today, and I'm going to tell you why and where it's headed. Monsanto. Monsanto, what are they known for? That evil corporation.
Roundup Ready.
Roundup Ready. They're known for plant genetics, aren't they? Okay? Some people think they produce seed, but they discover things, and it gets integrated into seed. They own some seed companies too, don't they? But really, their forte is genetics and developments, genetically modified plants. Last year, they bought a company by the name of Precision Planting. Used to be the machinery companies did their thing over here, genetics companies did their thing over here. Now all of a sudden, those two worlds have collided. Monsanto realizes the full genetic potential of their plants can't be realized unless they begin to take control of the planting process. Interesting. By the way, I think they overpaid for Precision Planting, but a neat company. Okay, Precision Planting makes a lot of those products I just showed you for add-on to the planters. Okay? Wall Street Journal, October 2nd, that's this year. Monsanto spends $930 million for Climate Corporation. The company, all it does was archive and analyze weather data. $930 million. I think they overpaid for that company too. Where's Monsanto going? What's all this information so important for? Okay? You know, farmers used to do what's called monoculture. We planted one crop, one variety, in a field at a time. What Monsanto is moving us towards is polyculture. Okay? Monsanto is making the statement that in cornfields, farmers might be planting up to 5 different corn hybrids within that field and matching those to the soil landscape. Data is everything. Precision planting, what you're able to do with this little sensor here is map surface compaction in the field. I talked about compaction before and the fact that USDA doesn't think it's a problem anymore. Here's a planter that was introduced, a concept introduced by Raven. Now what you can do is put 2 varieties in the planter and switch back and forth between the varieties. These are row splitters back here. One variety will be in the forward boxes, one hybrid or variety will be in the boxes back behind. We're working with some machinery companies right now. They're telling us 5 hybrids in 5 minutes. Out of Oklahoma State University, this is really interesting work. I'll give my colleagues some credit. What they're attempting to do is place the seed in the bottom of the furrow with the embryo side up and with the axis of the seed normal to the row. Because what do they want to do? They want to control the way the leaves emerge from the ground. They want to control the architecture of the plant canopy. They're suggesting with proper moisture and things like that, that this may generate up to an additional 14% in terms of yield. Think about where we're headed. By the way, one of the prevailing thoughts today is, if this plant here emerges 24 to 48 hours later than this one does, there's a negative yield impact. 72 hours, it becomes a weed. All it does is take away from the genetic potential of the adjacent plants. Can information. I like showing this. This is the fuel use rate coming out of a field. We know more about what's going on in the field than ever before. That's at 50 hertz. 50 times a second, I know what the fuel use rate is coming out of that tractor. I'm going to talk about data accumulation. We can look at all this. Right now, farmers are accumulating about 0.5 kilobyte per plant of data each year. Huh? 0.5 kilobyte per corn plant. That's what's being generated. Now the question is whether they capture it all. Okay? I'm making projections right now that for corn and soybean production in the U.S. we're about 2 petabytes per year. It's big data. Monsanto would love to have all that data too, because that will help them match up some of their plant genetics with what's going on in the country. If we throw in remote sensed imagery, and I'll get to that, worldwide that could go to 500 petabytes a year. You know, I jest with this, but you know, used to be I kind of thought I knew what a million was, and then you know, the federal government started talking about billions and trillions. Now we're talking about petabytes. That's a lot of information. I was right, Pat. One of the big things they're working on is drones, and everybody's concerned because of their privacy. They're flying a lot of those. Company right outside of Dayton, Ohio, Wolpert. It's a company that does a lot of, well, they've done all the LiDAR imagery for the U.S. They have 7 planes that they fly. They put this drone together. It's about $150,000 fixed wing aircraft. Has about 7-foot wingspan. Will stay aloft for about 45 minutes. Okay? What they're able to do with that is capture imagery over agricultural land. Now, they can't fly it commercially now because the FAA won't let them. Okay? Now, if I was a hobbyist, I could go out and fly that. I'm trying to understand the logic. This was actually flown with a manned aircraft over the Farm Science Review and some other places, but this is some near-infrared imagery they collected. What I want to show you is, here's the resolution they're getting it at. If you zoom in on that, that's about 2 centimeters per pixel at the ground surface. All right, what's that mean? Wolpert was showing me in Dayton, Ohio, after flying a farmer's field shortly after emergence, they were able to do stand counts on the corn plants in that field. This is technology that's available and ready to go today. The only thing that's keeping it from happening is the FAA. The cost to the farmers for this imagery, or excuse me, Wolpert's cost for generating this imagery and providing it within about 24 hours. They're saying 72 to be safe, but providing it within 24 hours about $1.70 an acre at 2 centimeter horizontal resolution. Okay? I get to thinking about things that are a little bit different from other people, and I apologize for that. By the way, here's an NDVI. This tells you something about crop health. Okay? That's at the Farm Science Review. I pulled this graphic out. And one of the things I start talking about is, what about data analytics and crop insurance? You know, right now, crop insurance is backed by the federal government, right? You think we're going to see transition to a market where the federal government no longer backs crop insurance? What I keep thinking to myself is, if I was a crop insurance company, I'd certainly want to know what the stand was that was achieved by the farmer. Because if their stand was 50 or 60% of what was necessary, I don't know that I'd be paying off fully at the end of the season for drought conditions that occurred later on in the season. Okay. By the way, what's going to keep, when the FAA releases some of the restrictions they have on drones, what's going to keep insurance companies from flying a farmer's field? Anything? You been on Google Street View lately? You check out what's in your garage? They are covering up license plates now. I'm going to quickly bring this to a close, but I put this up for a specific reason. We're having a recovery in this country, and a lot of people characterize it as a jobless recovery. And one of the things we know about industry is spending on automation is up 30 to 40% since 2008. We're actually bringing manufacturing back to the U.S. right now, but it's through automation. And this is perhaps the best example of this, and kind of goes